Okay, now we start working on the handlers. So there are two types of handlers we need to work on. The first one is the message encoder. The other one is the message decoder. So as I said that when the message is sent out, it needs to be encoded, and the Java object, because the message itself is a Java object, it needs to be converted to a byte array. And when the message arrives in the server, or the message is coming in to either the server or the client, then the message needs to be decoded, right? It gets into something, it gets in the server or the client, it needs to be decoded, and the byte array needs to be converted back to the Java object. So there are two different types of handlers. So encoder, it's an outbound handler. The decoder is an inbound handler. All right. So there's a question, why should we encode and decode them? If we don't decode, is it okay? The answer is no. Because when working with TCP, it is important to remember that the TCP is a stream-based protocol. Now, see, we use a TCP connection, which is a long connection, right? It's a keep alive, that connection keeps alive. So that's a long connection. So once it's a long connection, then it's a stream-based protocol. It's not message-based. That's why we need to convert the Java object into the byte array. And the boundaries between the messages are not preserved. We don't have any boundaries. We don't know how we can separate the messages. Okay? So on receiving side, what happened is, I'll draw a diagram here. So if we have a message, we say 100 KB, like it's sent out, okay, it's sent out. Now, because it's a TCP connection, so what happened is this message will be sent out in 2 chunks, or even 3 chunks. Okay, the first chunk is 30, the next one is 20, and then 50. Now that's the problem. Here is a problem, because when the message is split into 3 chunks, and these 3 chunks is sent out and received by server, like say the server picks up these 3 chunks. Now what happened is, the server don't know which chunk, or the server cannot tell how many chunks can be restructured back to the message itself, right? Without a message length field, we cannot reconstruct the original message from incoming chunk, because we simply don't know how big the message is, right? So when the server receives two chunks, 70, so the server don't know the original message size. So this, we can do nothing about this. So that's why we need a protocol. So we need to design a protocol into the encoding or decoding procedure, right? In network programming, a protocol defines the rules for how data is formatted and exchanged between the 2 systems. Okay, so like say that. So in programming, a protocol defines the rules for how data is formatted and exchanged between 2 systems. So we need to define the valid protocol, okay, so that both the server and the client obey this protocol, right? And when you send a message over the network, both the sender, like the sender can be a client or the server, right? And the receiver must understand the structure of the message. So which means we need to define a protocol that carries the information of the message. For example, we can put the length of the message into the protocol, right? So otherwise they won't be able to parse it correctly. So in our RPC network, what are we doing? Let's see, I define something like we keep it simple, okay? We defined a simple binary protocol to wrap every message we send. So what's our protocol? So like that, like when there's a message payload is sent out. When it's sent out, it's converted into a array. But first, before it's converted into an array, we need to do something on it. We need to identify a protocol. So in our protocol, okay, the first byte is the message type. The first byte is the message type, and the next 4 bytes, so next 4 bytes is equal to 1 int. So 1 int means the message length or message size. Okay, the message size, and then the message itself. So this is our protocol. When we send out a message, we need to manually, okay, put the first byte as the message type, and the next 4 bytes as the message length, and then the message itself. So when we finish this protocol, if we obey this protocol, this message, it's gonna become an array. It's still an array, right? Byte array. Message byte array. But now the byte array doesn't contain the message itself. It contains some extra information. That's what the protocol is used for. Alright? And now you can simply think about that. When this byte array, this big part, give me a second. This is a decoding. This is encoding. Okay, this is encoding. Oh wait, this is encoding. Alright, so when the message arrives, when it arrives in the receiver, it can be a client or a server, right? So we need to parse it. Now we are able to parse it because we know that this message follow the rules, the protocol rules. So we take read the first byte to get the message type, and then read the next 4 bytes to note the size of the message. Now, since we know the size of the message, and then read the remaining bytes. If the size of the remaining bytes is not equal to the size of the message, then usually it's less than the size. Read the remaining bytes. If the size of the remaining bytes it's less than the size of the message, then what happened is it tells me that this is a chunk. Then this is a chunk. So we can wait for the next chunk and check again. All right, if a second chunk comes in, like for example, we're using this as this is an example. So when the first chunk arrives, because this message, this chunk always carry the message information. It's not just itself. It follow the protocol, right? So they carry the extra information, the number of the message itself. So when it arrives, this server analyze this chunk. They know that this message size is 100K because I put it there, right? And then this one is not 100K, it's less than 100K. Then it wait for a second. It look at that when a second arrives, and it add them up. The two chunks adding up, and it's still less than 100K. So it waits. It's still waiting. And when the third chunk comes, all right. So the three chunks are adding up to 100, which is equal to the size of the message carried in the protocol. Okay, well, the server knows that the three chunks can be reconstructed back into the entire message. And then, yeah, we can do it. We can do our work to combining them together back to the message. So that's what the protocol used for, right? So this is how the protocol works. And we need to apply this protocol into the code that we are writing, right, in the next video.